Think forward. Think Research Channel.
The following is a presentation of the American Meteorological Society
and has been made possible in part by the people of Vizsla Incorporated.
Founded in 1919, 13,000 plus members of the American Meteorological Society strive to advance and communicate knowledge concerning the atmosphere and related sciences, technologies, applications, and services for the benefit of society. At each AMS annual meeting, time is devoted not only to presenting the latest in scientific discoveries, but also how scientists can translate this knowledge in terms understandable to other scientists, lay audiences, and the public at large.
It's my pleasure to have organized and to introduce the Presidential Forum. The theme of the forum is on urban weather and climate, and particularly we're going to be discussing the challenges that are caused by the convergence of climate change, urbanization, the migration to the cities along the coasts, and the resultant impacts as cities grow and get larger. I think it's especially important because my own view is the urban world is where the problems and challenges of the future will definitely be. Last year we reached a tipping point where more than half of the global population is urban. And by 2030, 60% of the world will live in cities. It's also a problem for those of us who do our research and do our operations and our education in the United States, because whereas in the early days of urban studies, the US was a leader. And unfortunately, we went through a low period in the 80s and the early 90s. And at that time, we saw the leadership go across the ocean. And we've started to regain that leadership. And I think with this meeting, we're making a bold statement that we really value and the importance of urban weather and climate. So it's my pleasure now to introduce the moderator of the Presidential Forum, Rosina Bierbaum, who will introduce our distinguished panelists. Thank you very much.
Good morning. Thanks very much, Walt, for setting the context for today's Presidential Forum and for choosing this topic, which is both timely and sorely underattended to. Urbanization is complicated, and it's proceeding at a frightening pace. And if you think about the increasingly complex and intertwined issues of urbanization in context with climate change, with biodiversity loss, with fisheries decline, with pollution, with desertification, it's clear that achieving a sustainable future requires the best and the brightest minds to tackle these interdisciplinary problems. We can't solve these problems one by one. There is no time, and it wouldn't work. One of the most gratifying things about being a dean at an interdisciplinary school is seeing that so many of today's students are indeed interested in working at the nexus of disciplines and wanting to become skilled at, say, atmospheric sciences and policy, or law and natural resources, or engineering and landscape design, or public health and meteorology. I would argue we need a different kind of professional to tackle these issues quickly so that the solutions to one problem don't exacerbate or create new problems. If you accept that the pace and the magnitude of climate change requires rapid and dramatic decreases in total world emissions by 2050, we need transformational, not evolutionary change in the design and conduct of our cities. And it is absolutely necessary, of course, that development proceed to give all citizens of the planet a better quality of life. But the historic carbon-intensive development route cannot be followed. We need a fundamental shift in our thinking. Development can exacerbate or ameliorate climate change, and unchecked climate change will certainly hamper development prospects for the developing countries of the world. So without further ado, let me ask Kai Lee to please come and take the podium and give us our first presentation.
Good morning, and it's good to be here, and I'm pleased to lead off this panel. First, let me ask for a show of hands. Please raise your hand if you live in a settlement with a population less than 5,000. Now, if you look around, you see that this is a relatively small fraction, parts per thousand, perhaps. And that's an illustration of how urbanized a world we live in, the people in this room. And I'd like for you this morning to begin to think with us about the relationship between urban areas, weather, and climate. This morning, I'd like to share with you three thoughts in the next few slides. First, urbanization is a major social and environmental force in the world, one with large implications for climate science. Urban economies are the driving source of greenhouse gas emissions, and urban populations are now facing distinctive weather-related risks from a changing climate. Secondly, human life and economies rely on nature. Urban ways of life address this reality in a way that we don't often think about. And third, there is a large opportunity before us to build a sustainable way of life as cities grow in many parts of the world. As you'll see, this is not a simple opportunity, but it is one where climate science can play an important role. If you look only at the very largest cities, those with over 10 million people living in them, you can see a fascinating evolution over the past two generations. Here's the roster of megacities, cities over 10 million. In 1950, you see that there was one, New York City. And if you look into the future, here's the projection by the United Nations Population Office. By 2015, they're projecting 21 cities around the world. Now, I think that most of the people in this room have been to New York. I wonder how many of us can find all 21 of the 2015 megacities on a map. So that's an illustration of how rapidly things are moving. As Baron Hunt will describe, these very large megacities are interesting objects to a meteorologist. But bear in mind, as Dean Beerbaum said, that most of the urban population today is in cities under 500,000. The demographer Joel Cohen dubbed the shift from rural to urban populations the population implosion. This is a graph, the numbers are a little too small to read, that shows the population trends from 1950 up to the present and projected forward to 2020. The solid line is the urban population, and this dotted line of dots is the rural population. You see that what's happened is the rural population is about at its peak right now, and the urban population is continuing to go up. If you look over a longer period of time, 200 years ago, about 1 in 50 people lived in cities, and by 2008, this number had risen to over 50%. This is a long-term trend that's driven by rising agricultural productivity, which has meant that fewer workers are needed to grow the crops, together with the rise of an industrial way of life, one that's built, of course, on fossil fuels, as you know. Now, here's what's probably the most important fact about this population implosion. Here again is from 1950, projected forward to 2030. And you see that in these gray bars below, the population of cities in high-income countries like the United States and Japan. The dark bars show that the growth of urban populations in low and middle income cities, countries that are poor or developing. This includes China and India, of course, which we've been hearing about, but also a lot of sub-Saharan Africa. It's not very well known that in sub-Saharan Africa there are already more urban residents than there are in the United States and Canada. We meet today in one of the most rapidly growing metropolitan areas in the United States. But Phoenix is a backwater compared to the burgeoning cities of China and India. That is so even in the global downturn, because the cities in the developing world are growing for reasons other than the immediate economic situation. UN demographers project that in only 20 years, as today's toddlers are graduating from college, there will be 75 million more urban residents each year. The population today of metropolitan Phoenix is under 5 million. So what we're talking about is urban habitats that can accommodate 15 Phoenixes each year in only 20 years. Now, what does that mean in terms of daily life? How will the tens of millions of people coming to cities live? The answer is they will live as all humans do today, from nature. Our dependence on the natural world's capacities to generate clean water, crops, energy, air to breathe, absorption of our manifold wastes, and to provide for recreation, none of this is obvious if you look around in an urban environment. These are what are called ecosystem services. But ecosystem services are essential whether you're in a city or on a farm. Consider the effort that it takes to put 15 liters of water into a bathtub in your hotel. It's the effort that it takes us to turn a faucet. But in a developing country, 15 liters of water must be carried, as you can see in the photograph on the right. And oftentimes, this amount of water needs to be carried several times a day. This is a photograph from Accra, the capital of Ghana, a city of somewhere between 3 and 5 million. Nobody seems to be really sure, where the water supply is very sketchy, certainly by our standards, and only a small fraction of the population has access to piped water. If you think about the difference between turning a faucet and carrying 35 pounds of water on your head, you can see that ecosystem services are something that matter a great deal in a developing country city. More generally, if you generalize to think about the ecosystem services from which people live in a city, you can see that, you can understand that a city can be envisioned as a physical and social mechanism to acquire and deliver essential human services to a concentrated population. In a city like Bangkok, which is shown on the map on this slide, the human population is densely concentrated, but the ecosystem services that they need, the water, both carried in and carried out, energy, pipelines, railroads and highways that will carry energy and materials and information needed to organize the economic activities of the city. All of that needs then to connect dispersed sources to a concentrated source. So what we see is the radiating network that comes out of the center of the city, something that I think we're all familiar with. So that's the physical part. The physical part is called infrastructure. These pipes, pipes and transmission lines and highways and so on. Infrastructure, of course, is a big word now in the United States because it's one of the things that we're looking at in the economic stimulus package. But together with the physical infrastructure, there is an essential social component to the way the city operates. The social component includes markets that link consumers to producers, and as well as a governance system that structures the market and that will regulate things like air pollution, and together with many other ecosystem conditions. If you think back about the woman carrying water in Accra, you can see that people in developing country cities don't go very far. The water that they get is water that they necessarily obtain from not very far away because they simply can't carry it very far on their heads. The environment that they affect with their cooking fires and garbage also tend to stay quite local. As cities become richer, they have handled those localized problems. And that is why the air over Los Angeles is cleaner now than the air over Mexico City or Bangkok. So there's an important generalization in looking at the spectrum of cities, from cities in poor countries to cities in rich countries, that increasing income changes the nature of the environmental problems faced by a city. That in a poor city you have localized problems, and as you increase the income, so that these local problems decline as the income increases. Similarly, if you look at a wealthy city like Phoenix, we don't have very many local problems here. We can just turn a faucet to get the water in the tub, but we're generating a lot of carbon emissions as we move about and work and live in a city like this. So we cause a lot of decentralized global problems, such as carbon emissions. And then in the developing world, in a place like China or India, you tend to have this a pattern where you have wealth has increased somewhat, and as the things like smoke go into the air, you get more severe environmental problems. So what's going on is a transformation from places like, from a profile like the dark one toward this gray one, with this dotted line as an intermediate kind of case. What is driving the transition from poor to rich is the process called globalization. And remember I talked about markets and governance a moment ago about cities. Markets have now driven globalization far ahead of effective governing institutions. And that's why we have a climate crisis. Catching up with the planetary scope of radiative gas concentrations in the atmosphere has been on the agenda of scientific and governmental institutions for decades. And we're not going to finish the job in Copenhagen 11 months from now. So this is something that we're continuing to work on. Beyond the generalizations shown in this slide, however, it's important to realize that each city is unique. The variations among geographic setting and history make it harder to transfer lessons from one city to another. Urbanization is both a threat and an opportunity. It's a threat because of the immense challenges to public health posed by rapid urbanization in developing countries, coupled with the challenges to planetary ecosystems from climate change and loss of biodiversity driven by urban economies in a global system. There is much to do, both in modifying behavior in institutions as well as in building infrastructure. Yet urban changes are little noticed and little attended to in both science and public discussion so far. Urbanization is also an opportunity because humanity will more than double its urban habitat in the next 50 years. This is a chance to do better, but it's a chance that will only be realized if lessons from the failures and successes of the rich world can be transferred effectively to the developing world. As you have seen, I think, in the coverage and news surrounding the Olympics, we are not yet doing very well with cars in China. There's much that needs to be done. Much of it is not very visible from the mostly urbanized countries like the United States. One final word. Sustainability of cities includes resilience in the face of a climate that is no longer stationary, a situation where past climates provide only a first step in analyzing the droughts and floods and severe storms to which infrastructure and governance need to be designed. This is a large task for which science, climate science at the frontiers are going to be needed. Let me now turn to my colleagues on this panel to explore that thought further. Thank you for your attention.
Good morning, ladies and gentlemen, friends and colleagues. As international member of this panel, I welcome this session on climate and environment. Cities are recognized as a critical issue for societies worldwide, as the United Nations organizations have demonstrated. There was the Habitat conferences, the World Meteorological Organization, to which the United States always contributes greatly, for which we're all very grateful, and also sends a very healthy delegation to, which other countries could well copy. And so the WMO actually introduced special programs on urban meteorology in 1995 at their Congress, and now they have their multi-hazard early warning system. The importance of cities has already been mentioned, the growing population, the responsibility for perhaps 80% of greenhouse gases, but more importantly, particularly for the poorer people living in cities, as the previous speaker has mentioned, there is greater vulnerability to hazards, and these become worse with climate change and perhaps as cities grow. I believe that a new overall conceptual structure may be needed to enable meteorologists to interact effectively with other scientists, including social scientists, engineers, planners, and also the wider society and politicians. In some cases, integrated systems approaches may be needed with new forms of feedback, but innovative individual initiatives are also essential, as communities and around the world have already demonstrated. My remarks are based on many joint projects and interactions with scientists, policymakers, and even politicians like myself. Meteorology and environment involves many global regional interactions, and they both upscale and downscale. First of all, I want to emphasize that there are very substantial research questions about the climate, in meteorology and environment of urban areas. My colleague, Professor Fernando of Arizona State University, well-known Greek scholar, has invented this word polymetrics for this subject. I was not meant to use irony in American talks, but I thought that you might appreciate it. Urban areas are affected by regional climate, environment, and global, and the whole global climate, as you can see on this sort of downscaling aspect. And of course, some of the local regional environments are not to do with climate, but to do with human activities such as deforestation, desertification, and so on. Detailed modeling is needed for the urban areas, for mountains, for coasts, to account for surface changes, orographic effects, precipitation, and pollution. I think it's worth making a distinction between these specific types of modeling and those which are downscale regional models covering the whole of the region. It's very important, of course, to keep remembering about the upscale processes. It is the urban areas that are producing most of the greenhouse gases that are affecting the global climate, but also, of course, as Ramanathan has pointed out, it's the big urban areas in particularly Asia are producing brown clouds that are affecting the climate over many parts of the world, and we have to very much consider that. But just to remind ourselves about the issue of global warming and climate change, I went to a meeting in London in which there were 600 civil engineers. We were meant to be talking about climate change and engineering, and they said, Professor Hunt, when are you going to stop believing in climate change? Because for the last 10 years, the global average temperature has not increased much. Of course, we had a very strong El Nino in the late 90s, and it has been static. However, if you look at Hansen's webpage at NASA Goddard, and now on the Met Office webpage and so on, Hadley Center, you'll see, of course, that over the land areas of the world, the last 10 years, the temperature is rising inexorably, typically by about 0.3 degrees per decade, and that is, of course, expected by the models to continue over this century. But in fact, it's curious that the IPCC, which always focuses on this diagram, has actually clearly misled people, including politicians. And I hope all of you here will keep reminding people that if you look over the land, it is indeed rising. This required a parliamentary statement in the UK in July 2008. I'm sure you all read Hansard to be informed on these matters. Some of the areas of the world, the temperature, of course, increase has been even very much greater. I hope you can all see this slide, and you can all recognize that this slide is out of date. This is, in fact, the Antarctic Peninsula. We're looking south. And around this area here, the temperature has increased by 3 degrees in the last 50 years, according to the scientists, the British Antarctic Survey, and other international scientists. This is a good example of local meteorology plus regional and global effects. What's been happening is you've been having an increase of westerly winds as opposed to formerly the downslope easterly winds. These westerly winds impact on this peninsula, and because Coriolis, as you recall, is in a different direction in the southern hemisphere, it turns right when it hits this impact, and bringing the warmer waters here, warmer temperatures over the peninsula, as detailed studies have shown. In fact, of course, the same Coriolis effects are relevant for very large urban areas, for mountains. And as we get to cities becoming larger and larger, these kinds of local effects begin to be more important. Of course, as you know, when cities are warm at low temperatures, the Coriolis effect turns them in a different direction in the southern hemisphere to the left, in the northern hemisphere to the right. The other very important regional effect of climate change is and this is perhaps the most serious one of all, is the higher likely frequency of summer blocking events. This is a graph taken from a study by my colleagues Cazou, Dr. Christophe Cazou and Dr. Terray and Gouliardi in France, using global climate models. And the important thing is this red dashed curve, which shows that the probability of summer blocks of 12 days, 16 days, 20 days, even 24 days are going to be comparable with the kind of probability that we have now. That is extremely serious for urban areas. It leads to, of course, more drought and higher temperatures and probably more pollution. This can be devastating. Of course, this kind of phenomenon is associated with deeper mixing in the troposphere. We're having more two-dimensional light flows, and we're having fewer winter frontal blocking events. In fact, it's the winter frontal blocking events, such as we've been having in Europe in the last month, which currently causes the biggest urban health problems. It will be a big transition. Now, when we're considering these issues, it's worthwhile, as many studies have now shown, starting with the United Nations International Decade on Natural Disaster Reduction, of considering hazards and impacts separately. Climatic and environmental change are producing hazards, and these then produce impacts. In the past, there's been a great focus on the physical impacts. And indeed, insurance companies are particularly focused on that. But now insurance companies, and I am associated with a group in the City of London, are looking at the societal impacts. In fact, societies that don't have the resilience to withstand impacts, in fact, cause more financial damage than the ones just associated with the physical vulnerability. So we have to consider that. We have to consider the fact that some hazards only begin to be significant when they're above some critical value, a critical hazard level. The other point is that, of course, many of hazards come in combinations, so that the combined impact is more than the sum of the impacts of individual hazards. Because cities can as it were, the damage to a city is cumulative. Urban effects produce an additional hazard. We can have higher temperatures in cities. We can have higher levels of pollution. We can have higher floods, as we saw in Britain. If you have the cities, the water funnels between houses, the currents in a city are higher than the currents in the country. A Dutch colleague made the suggestion that the ground floors should all collapse. It's a very ingenious engineering method, so that the currents will be lower. But seriously, of course, we can have higher impacts associated with that. So the scientific question we have then is, what are the effects of climate and environmental change on these, both the hazards and then the impacts, defining these critical hazards. And of course, the critical hazard levels or the critical impact levels will be very different in different cities. One always sees with tropical cyclones impacting on cities, for example, in the United States, there's a much lower level of casualty than there are in cities in poorer countries. The other question is, what happens as cities become larger, as we've just been discussing. So here is London. Here's London's rubbish being taken away. One of the big points about cities is that they have a lot of rubbish, and therefore the footprint of cities is just enormous. And of course, with recycling, one hopes that will change. London is an example of a coastal city, and coastal cities are one of the set of cities that are very vulnerable to climate change. In fact, London has a flood protection system, but further downstream of that, the flat areas in the estuary are liable for flooding, and indeed there may be some so-called retreat. The pollution you see here in London is quite considerable, and one of the measures taken to do that is to remove traffic. Although this has happened in London, I'm afraid the voters have voted against it in Manchester and Edinburgh, and they have hesitated to do so in that progressive country, the Netherlands, as well. So we're all waiting for some inspiration that will make people get out of their cars around the world. The other, of course, important feature, as we've already, is adaptation. I just want to mention is that there is a very important program of understanding and modeling air pollution in cities, providing real-time forecasts every day. This is a program sponsored by the European Space Agency, organized by the so-called GEMS program, which was first led by the late Tony Hollingsworth, and now Adrian Simmons, and he'll be talking at the Hollingsworth Symposium this week. The modelling of temperature in cities is extremely important, and there are a number of projects, including one, the LUCID project, which will be described at this conference by Professor Belcher and Bohlenstiegel. If we turn to Phoenix, Professor Fernando's team, which will be reporting this week, here is the through infrared photographs. You see the hot area in the center. You see these mountains, which these rocky mountains can be even hotter. This is an example of an irrigated desert city. In fact, in the cities as a whole, it can be cooler than the surrounding areas, as it is in New Delhi because of it being an irrigated city. But in the very city center itself, we have very high temperatures, sometimes, and in the evening, more than 10 degrees in excess, and this excess temperature is increasing by 0.5 degrees C per decade. Of course, this didn't exist 40 years ago when there was no air conditioning and people used to sleep outside. It's very agreeable if you do that in Phoenix, as I know from my experience. You can't do that in your hotels, however. The impact trends that we have to consider through research, which I won't be able to talk to, you can read the paper. Clearly, we have to think about these impacts as they're growing with climate change and how the impacts are varying with urban. I just want to point out two important points. One of them is the scale of the hazard. If the scale of the hazard is determined, let's say, by the precipitation event, or perhaps by a tornado, or perhaps by airflow going around a large city, then the hazard scale will be less than the city scale for very large scales. And also the city scale may become comparable, larger than the Rossby deformation radius. But for other cities, other problems like heat and pollution, the hazard scale will be the same as the city scale. This provides you with, I think, a methodology for looking at the problem. If we deal with climate environmental change, as our chairman mentioned earlier, we have the policy objectives of mitigation, adaptation on the short term, particularly reduction of impacts, and adaptation on the long term. We also increasingly have to think about the security and stability of societies. You can meet all these objectives, but if the result is unstable and insecure, it's no good. And finally, we have to deal with using various action methods. Sometimes it's energy, low carbon energy, energy use, land use in buildings, and transportation. One point I particularly want to mention, in fact this is an international conference, is that if you do something, for example, suggestion of reducing air transportation, that will have a devastating effect upon countries in for example, Africa, providing tropical products to Europe. So we have to think about these international things. The three methodologies that I just want to mention, one of them is the importance of information, demonstration, prediction, and warning. The Americans are doing quite well, as is the Dutch, in having a nice system in which you can demonstrate different methodologies. That's the only way to persuade people, I think. We have to consider multi-system interactions. And I think the really important final point is that we have to consider feedbacks from the users, the people experiencing and participating, back to the people making the predictions of weather and climate, so that we can keep providing information precisely in the form that they require. Thank you very much.
Well, indeed, it's a great pleasure to be here, and I thought that the title that was in the program was a little bit long, so I shortened it to this, and I give my apologies to Bob Dylan. I'd like to start off with a statement that even with a stationary climate, we are in for some serious trouble in our coastal cities due to the concentration of population and resources in the coastal zone. To illustrate this, just take a look at the events on September 3rd of 1821, when a Category 3 hurricane swept up the United States eastern seaboard. Moving at about 50 miles per hour, it traveled from North Carolina to New York in 8 hours, right up what is now the New Jersey Turnpike. This particular slide shows an estimate of the damage from that hurricane on the Fujita scale done by Booth et al., who used historical counts and a simple hurricane model to actually describe that damage. And this particular diagram shows a reconstructed hydrograph for Manhattan on September 3rd, 1821. The predicted tide for that day is the solid red curve shown here. The dashed red is the storm surge that Jeff Donnelly from Woods Hole drew based on the observations of William Redfield. Note that the storm hit New York at low tide and the water rose 4 meters or 13 feet in 1 hour. This is pretty significant storm, as one could say. But back in 1821, there was no New Jersey Turnpike, and there were but a few fishing shacks on the barrier beaches. Today, in this particular region, we've built cities on some of the barriers that were impacted by this storm. More than 31 million people now live in the coastal counties that were struck by this hurricane. And sit here and imagine trying to evacuate those people. If a similar hurricane hit today, the losses of people and property would be staggering, probably more challenging than what we faced in New Orleans. This points out, of course, the whole issue of population and the population trends and the population trends towards the cities and towards our coastal areas that's been discussed in our previous two speakers. This particular graphic basically shows the crowded coast population trends in the United States, and some of the characteristics are clear. Half of the Earth's people live near the coast and less than 1/5 of its landmass, and coastal populations are growing at a fast rate. Coastal counties contain 53% of the population on 17% of the landmass. Those areas gained 38 million people between 1970 and 2000 in the United States. And while population growth and coastal development do give rise to economic benefits, it also destroys critical habitat, green space, and biodiversity, areas which have actually provided barriers to things in the natural world. And there is certainly a tension in our coastal cities to finding the right balance between economic growth and mitigating those effects of growth. If we now take and add sea level rise, one of probably the most important climate trends to that area, you see that we are just increasing that tension. And so sea level rise is probably the greatest climate change threat to the coastal urban environments. And the convergence of that sea level rise with these population trends can be dramatic. This obviously shows the IPCC's diagram showing the sea level rise estimates. You'll note the large uncertainty, of course, for projections in the future. And it should be noted that observations today of sea level rise are even higher than the IPCC prediction in many areas. The probable cause of that is probably a lack of understanding the thermodynamic response of the ocean and the interaction between the atmosphere, ocean, and ice or land that you find in coastal regions. And keep in mind that nowhere probably on the Earth is the convergence of land, ocean, atmosphere with societies more dominant and more prevalent. The thermal expansion is more than ice melting in the oceans. The ocean does expand when it warms, and understanding that thermodynamic response requires more than observing the surface of the ocean. You actually must be able to determine the entire water column response. But taking this sort of global picture and seeing how it actually projects into, again, this northeast corridor in the United States, you see here that a sequence, and I think I can try to run it again, or maybe I can't, but I think you can begin to see going from a present status of sea level to an actual increase in 1 meter intervals, what would happen to the erosion of coastal environments along the northeast corridor. To the impact on sea level rise on coastal cities, you can see, is going to be potentially very large. And 2/3 of the world's largest cities are on the coast, as was demonstrated by Kai. According to the just released United Nations State of the World Cities report in 2008 and 2009, there are 3,351 cities in the low elevation coastal zones around the world. Of these cities, 64% are in developing countries. Asia alone accounts for more than half of the most vulnerable cities. In Asia, 18 of the region's 20 largest cities are either coastal, on a riverbank, or in a delta. In the developed world, 35 of the 40 largest cities are either coastal or situated along a riverbank. With sea level rises, populations of cities such as Mumbai, Shanghai, Miami, New York City, Alexandria, and New Orleans become extremely vulnerable to surge-induced flooding. In New York City, if sea level rises 1 meter, a 100-year flood becomes a 4-year flood. All right? Taking this regional perspective now and making it down into a level where decision makers of cities might find information useful. And this is a diagram of Charleston and the associated inundation from shallow coastal flooding and sea level rise. With a sea level rise of 1.6 feet or half a meter, the current flooding conditions under a 7-foot tide here are shown, and they could potentially occur on 289 days as opposed to 2 times per year presently. And a 7-foot tide measure is the current mean low water datum. It's what the Weather Service actually uses as the threshold for shallow coastal flooding water. What I think is interesting and what I want to illustrate with this and going to this level of detail is what is now available for planning and for abilities to, I mean, you're almost looking now here at the city, street level and looking at the inundation that one can have in these coastal cities. Stepping back a little bit, though, coastal cities are also impacted by local human practices and land use. Compared to 30 years ago, we have certainly greater populations leading to more pollution. Primary sources of pollution in the coastal areas, particularly in the oceans, is the fertilizer usage and the drainage of that usage, which eventually ends up in the coastal ocean. That fertilizes the ocean, resulting in waters blooming with so many plants that oxygen is depleted. The other major source of pollution, of course, is sewage and chemicals, some directly toxic to marine life and humans, others transferred through the food web as poisons and carcinogens. There's certainly greater pressure on resources when you build up these great physical environments, and the loss of coastal barriers and marshes who have provided buffer zones and natural habitat to actually give you a little bit of a barrier or response and able to look at variations in sea level and other natural infrastructure changes. Increasing the population leads to increased infrastructure, which is vulnerable to sea level rise, and increasing the risk to enhanced waste disposal, food supplies, transportation systems, and water supplies. Just think what would happen in these environments with a sea level rise, the inundation of waste into the coastal oceans. And in fact, over the past 4 decades, we have seen more algal blooms and more types in more places along our coastal areas and coastal zones. This is an animation of the red tide in the Gulf of Maine in spring 2005. It's a computer model that shows how the pattern of nor'easterly winds, which particularly dominated in the spring of 2005, can push Alexandrium cells down the Gulf of Maine into the Massachusetts Bay and Cape Cod Bay. In typical years, prevailing breezes from the southwest usually blow these cells out to sea before they can flow into the bay. And this particular red tide, of course, is very detrimental to certain species of shellfish in the food web and also can produce human health hazards as well. Bringing larger populations to the coast will require a lot more care and management as we see these types of biological disturbances occur. Red tides are just one example, and in fact, in place now is rudimentary testing in our coastal waters for red tide. Our potential future may require an expanded and broader suite of biological and non-biological testing, in particular for things such as cholera. We're changing the chemistry in other ways of the ocean, and it's not clear how that chemistry is actually going to eventually affect our coastal regions. And in fact, this particular diagram shows the basically the uptake of carbon dioxide by the oceans. You will notice here that this is the anthropogenic uptake of the carbon dioxide, and you will see that the largest sort of centers of uptake indeed occur in the North Atlantic and in the Southern Ocean regions here. And this particular acidification of the ocean is one of the growing sort of victims of the climate change arena. And in turn, this basically certainly changes the seawater chemistry, and which in turn impacts most of our shell-forming organisms. Okay? I'm going to skip this one. what is going on, in particular in our coastal areas from the science point of view, that can help us to predict and bring more information to decision makers in planning and operating and managing city environments. Certainly, as an atmospheric scientist, I've certainly been now in charge of a oceanographic institution, I've become increasingly aware of the differences and the challenges of really putting together an integrated atmosphere, ocean, and land observing system, which are so critical in looking at the coastal cities and coastal regions. Beginning with the Argo profiling float array, which is really basically the radiosonde of the ocean. Unfortunately, this profiles just the first 1,500 meters of the ocean. And the issues are that we are not essentially constraining our climate models in part because we have not initialized the deep ocean, and we're missing the entire water column thermodynamic expansion. So we are still challenged in many ways to really get our climate models right in order to be able to look at these sorts of dilemmas that are facing our cities. But help is on the way, and in fact, over the years, oceanographers have made huge strides to make ocean observations. They have engineered robotic vehicles, undersea cabled networks, and moored buoy systems, and are in the process of really planning and have actually planned, both through NOAA and NSF, ocean observatories that hopefully will be coming online and working in many ways like our wonderful atmospheric observing system on a 24/7 basis. The fruit of some of these observations is actually bearing well with support from NOAA. Scientists have begun to collaborate to create a Northeast coastal ocean forecast system, an integrated atmosphere ocean system that includes mesoscale meteorological models, an unstructured grid finite volume coastal ocean model and wave model, and generalized biological models, all important for coastal regions. It generates 3-day forecasts for icing potential, water temperature, wind speed, and other conditions in northeast coastal areas. What sets the system apart from other forecast models is its high resolution, which allows forecasters to make detailed predictions about conditions within specific bodies of water, such as bays or harbors. The system is now running 24/7 in experimental mode, and data from it is being fed to local weather services, the Coast Guard, and the Massachusetts Coastal Zone managers. Researchers are now experimenting with tuning the model to try to forecast storm surges, inundation, and beach erosion in the specific coastal locations. And at the level of nor'easters and other storms, which are more frequent than hurricanes, but are still quite punishing. Finally, a couple slides. Coastal cities have increased their vulnerability, but also can be part of their solution. And I put here just a set of bullets that I've come across. They're for discussion, but certainly strategies for containing costs of short-term disasters will be equally helpful for addressing long-term sea level rise and other climate change impacts. And as been noted, investments in public infrastructure should be tied to resilient siting and design, which of course brings up the whole issue of what our $700 billion economic stimulus package should be doing in terms of actually enhancing infrastructure. Strategic and aggressive approach towards coastal habitat acquisition, restoration, and remediation and creation, the ability to restore natural buffer zones. Or how about thinking about a LEEDs-type standards for resilient structures, like we have for buildings, integrated regional and coastal zone management plans, and energy-saving and fossil fuel reduction technologies. And of course, the ability to influence their own changes in lifestyle behavior, and ultimately, if everything else fails, certainly a discussion on how we are going to relocate some of these massive cities on the coastal regions. The science agenda must develop a systems approach to modeling and observing coastal regions and cities. And what I mean by a systems approach is very much what I think Julian has said, this approach to connecting atmosphere, ocean, land, social infrastructure, and human practices that are actually solving some of the critical problems in places that are so vulnerable. Enhancing the integrated observing system, working with city frameworks to provide science into decision-making processes. And although I focused on the Northeast because the topic is so large, I had to focus somewhere, many of these problems are going to be faced throughout the world, and international cooperation and coordination are very essential. I think it's also important to realize that many coastal cities are also desert cities. Okay, and problems associated with desalination and the use of water and energy are also important to be considered. Finally, Pursuing an adaptation focus as well as an energy or mitigation focus. I often think that mitigation is cast in terms of the energy discussion. I would say that adaptation can be cast broadly in the water discussion. Thank you very much.
Good morning, everyone. Within this forum, we frequently talk about society and society, the two different ones, the society of the American Meteorological Society and how we come together, but how we come together really to serve the greater society. And I think you'll agree with me, our previous speakers have done a wonderful job reminding us of where large parts of that society actually reside. Within our cities, we've seen the population trends there and what's forecast in the next decade. And within our coastal region today, as Susan just reminded us, we have more than half of our population in coastal regions. So when we look ahead, the challenge for us here, and what I'm going to try to motivate, is people to think more about urban weather and climate services and how we move forward. We've talked quite a bit here about growing cities, and I think a very strong case has been made about the increasing vulnerabilities, not only those brought about by climate change, but other impacts that large numbers of people being brought together. So it's very clear that we need thoughtful and coordinated action. The Society has recently taken on, in the last couple of years, the development of an enterprise, which is a forum to bring together the various sectors of the society, the public sector, the private sector, the academic sector. Well, I would say that all of these sectors need to have a role in meeting the kind of services, in providing the kind of services that need to be provided for the public. And in fact, we need to go beyond this enterprise and train more into that. Certainly in the public sector, it's a basic expectation from the public sector that we promote the kind of policies that need to be in place to protect our citizens. It's one of the prime things our citizens expect from us. And also that we deliver the services to keep people safe. And clearly, as I'll highlight in a few minutes, we do these type of things, but more is needed. The academic sector has a very strong role to play as we address these challenges. With respect to continuing to build on the strength that they have in basic research to meet the challenges. The case has been made already by, in particular, Julian and Susan about the gaps that we have with respect to understanding the science. And I think also a case has been made, and Rosina highlighted in his comments, about developing the next set of leaders for our field that will need to pull not only from our traditional disciplines, but stronger disciplines. And it's certainly the academic sector that's going to help us do that. But I think further, they provide a focal point for us to bring together the kind of discussions that need to happen as we move forward. And certainly the private sector has continued to lead the world in this country in delivering services that serve our population so well. And they're going to be called on more and more to meet the challenges in these city infrastructures, not just with the businesses that are there, but providing the very tailored services that are going to be expected by people that we won't be able to provide. So I think there's a call for all of us here. But before we get into that, let me spend a few minutes on kind of the baseline of where we are. I think we have services in this country that we can really be proud of. I know in my career, the Weatherman has come really off of the comics page onto the front page and onto Wall Street in terms of people being willing to make decisions on what we provide. And there's certainly a variety of services here. Starting in the top left-hand corner, I've highlighted water. And water really is at the intersection, I think, between climate and weather. We provide a vast array of services now, a lot of focus on flood, but increasing focuses on extremes, particularly with respect to drought. In the right-hand corner here, I've actually highlighted what's a run of what we call our high-split model, which deals with projections of hazardous material. And I think, again, we can be really proud as a society, and particularly after the 9/11, how we've come together to do a better job ensuring that emergency management community has the information that they need as they have to respond to both man-made and terrorist attacks there. The bottom right-hand corner here highlights Hurricane Katrina, and there's quite a bit of advances that have been made there, notably in landfall forecasts, but in those types of services that we provide in warnings for people to take protection and protect their property. And then in the final quadrant, I've highlighted the drought forecasting. And this is certainly a unique product. And I put it up here in particular because it highlights a partnership between NOAA, regional climate centers, and academic community. So it's actually one of the few products we have that on a routine daily basis brings together parts of the enterprise. But I think that it's not a newsflash to people in this room that there's really significant knowledge and capability gaps that remain. So if you'll bear with me, I want to go around the circle one more time and just highlight those. With respect to water, certainly accuracy of our forecast needs to be improved, but I think even more fundamentally, we need to do a much better job being able to forecast the whole water cycle. We need to do a much better job putting together the groundwater with what's happening on the surface and to be able to bring in the human decisions that control the water infrastructure in this country to be able to improve the kind of services that are there. I think within the emergency management community and working with the emergency management community, as I said, we can really be proud of the kind of services that we provide. I'd like to highlight that it's really been underpinned by a very long relationship there. This isn't where you swoop in and do this, but there's much more that needs to be done. I come from Washington, D.C., and I can tell you that we're in a frenzy there about the number of people that are coming for the inauguration and how we'll deal with that. And certainly terrorist threats are a main part of that, but environmental information is really key, and the same kind of discussions could be happening in different scenarios. And we need to be able to move forward where the decisions in the future aren't that we close all the bridges, from Virginia to D.C., and need to be informed by how we would actually take care of the people in the city as opposed to continually moving them out. With respect to Hurricane Katrina that's shown there, we have made those great advances, as I highlighted, but the reality is we understand far less than we need to with respect to hurricane intensity. And as Susan really just highlighted there, and that really makes a difference in terms of actions that need to be taken. And then finally, with respect to climate, so much more needs to be done and is really a very strong focus, not only within NOAA, within our community. This drought monitor product is a great product. However, it would lead you to believe when you look at this that every place that's red on the map has the same sense of urgency and demands the same attention or action, when in reality that isn't true. You expect that to be red in Southern California at certain times of the year. So in looking forward and how we move forward, I do believe there needs to be, and there is, very energetic national discussions and international discussions on how we mitigate some of these things. But I would say that what I want to talk to you about is kind of the regional forum and focus on places that can really make a difference. And I want to use as a highlight here one of 9 of NOAA's regional integrated science and assessment products. And I obviously chose this one because we're here in Phoenix. And this is a project that is hosted and run from the University of Arizona. And the concept of these projects are really to focus on places and problems, So the focus isn't we've got services and we're going to give them to you and you're going to like them. But it's really the focus of how do we really address the needs that are there. And I think you'll agree with me with the long list of items that are on this thing. They're quite It's quite impressive and also pretty overwhelming. And I can tell you it's especially overwhelming because I know how little money is going into this project. And the concept here is that we have people on the ground that are informed in weather, climate information, that are meeting with decision makers there, people that run dams, people that do city planning, and we work to provide them the kind of information that's needed. We work to understand what decisions they're trying to make and match that with information that we have. I think the other thing that this really highlights here that was addressed by, I think in particular, Julian and Kai, is the breadth of information that's here, that is things that are very important within the cities, like air quality, but how they're impacted by what's going on around the cities. So even if the incident isn't within the city, you're really influenced by that. So the economy here, for example, with ranching and how that feeds back into the economic structure of Phoenix for one of those things. These have been, I think, a great success for NOAA. We feel that we have far too few of these for the challenges that are out there, but at the same time, we feel that this has really demonstrated a way to move forward. And I would say that as a nation, one of the things we need to do is begin to establish a national structure that would do what this RESA activity is doing, which is create a forum and a mechanism where we can put environmental information providers on the ground with the actual decision makers and begin to inform that. I want to, so I think that's one way to inform, and one of the prime ways to inform decision makers there. I do think, and I don't want to shirk from the aspect of when I talked about the federal role, two parts of it, and the other part is public policy. And within NOAA, and linking again to Susan's talk, we have been very focused on a program we have called Coastal Zone Management, where we actually have a responsibility to work with all of our coastal states, including the Great Lakes, addressing their coastal zone management plans, which include, of course, infrastructure planning. I think one of the things that's been clear from us doing a very active public dialogue, and I would note that all of this has been post-Katrina, is that as a nation, we firmly believe that we've got to adopt some national policies in moving forward with that program. And one of those policies or priorities needs to be built around resiliency, that we need to ensure that as we invest federal dollars, that it's actually moving our cities and our coastlines to a more resilient structure. So finally, I'll just really wrap up in these last two slides that our actions as we need to move forward here need to be driven by decision makers. We need to really come at this with what problem are we trying to solve. As been highlighted by previous speakers, we need to expand to include diverse fields to formulate our useful services. So I would say in looking ahead 5 years, if we could have a large number of people in this room or similar forums that were coming out of social sciences in particular, I think we would be in much better shape to address these problems. We need to move forward in a way that there's a sustained relationship between the people that are making decisions and the information providers. And then I would be remiss if I didn't make the point that there needs to be a very strong research program, not only in physical sciences, but also in social sciences, in informing how to put us in a position to better provide and influence decisions in a productive way. So my last thought is one that I'll attribute to Bill Hook, because anybody that knows Bill has such wonderful, knows how wonderful he is about this. But he highlighted this morning that as a nation, we really feel let down from looking at the economic picture. We feel very let down from the economists and the regulators and the people that were watching our financial markets and things for us. And I think that it's really incumbent upon us to make sure that isn't happening, that people aren't coming to look for us in the future about where were you with the kind of environmental information we needed to help us make better decisions. So I really think that we need to leave here with a sense of energy and trying to understand these problems and doing our best to address them. Thank you.
So first, let's start with what does this mean to me in my career? Kai, we got a number of questions about that there are different issues related to urbanization, whether you're talking about the poorest countries of the world versus the middle or rich income countries. And so how does that context, that state of flux, that capacity change the task for the meteorological community to supply necessary tools quickly?
Yes, I think the base, I'm an outsider, so I don't know how meteorologists actually, how your career incentives flow. But the basic task, I think now, is to build more effective communications between the meteorology community and its users. This is a theme that Mary brought up at the end of her talk. Including potential users who are in the developing country cities that are facing both their endogenous growth and the problems related to climate change, particularly in those coastal cities. How you go about doing that, I think, will vary by institution. People who are in academic research already have access to a global network of collaboration. And I think what we need in public policy is greater funding and support for research that works with coastal data sets, for example, in other countries. It's less clear to me how that works in the production and delivery of specific weather products. So I will defer to other people, but that's a beginning.
Any comments from the panel on that, Julian?
I went to the zoo in London with my grandson at half term and saw all these extraordinary conservation projects around the world. And I realized that many of these conservation projects are in fact monitoring all sorts of environmental processes. But actually, I think you referred to using data sets, but the biggest data set is actually what the animals are doing, the vegetation is doing, and so on. And I think one of the interesting, greatest challenges to young people beginning to enter the world of environmental climate is to really try to understand this sort of qualitative data and relate that to sort of modeling. Because actually the qualitative data is actually averaging in time and space and gives you all sorts of interesting information. And we're now finding that animals, I was interested to know whether in Susan's talk, she didn't mention the fact that they are now monitoring, putting tiny instruments on seals in the Antarctic, and they go diving down, and they can telling us almost as much as these fancy, much more expensive underwater sampling. So there is an extraordinary actually feedback into real hard science from really working very closely with these other disciplines, and I think that's a very exciting avenue for young people entering this world.
Yeah, just to follow up on that a little bit, developing a sort of new effective research and decision support teams to be able to do that. Putting together groups that will look at integrating data from multiple sources, non-traditional sources, meteorological sources, your SEAL data, they call the SEAL oceanographers, and quite remarkable data sets. And that whole infrastructure, that cyber infrastructure that's actually needed in order to data mine to actually be able to attack some of these critical problems that are facing our cities. Exciting times.
So the second question on what does this have to do with me is quite related. And it said the speaker's abstracts implied a systems approach was needed. How can meteorologists work with these other disciplines? And in particular, though, what structure is there domestically or internationally to do so? And aren't you trying to make us think more messily like engineers or EGADS, ecologists? And I think, Julian, that one was directed at you.
I trained as an engineer and then did a bit of maths and then finally ended up in meteorology. But I think the interesting point about an engineer, as you all know, is that if he or she sees something and they don't understand it, they kick it and they see how does it respond, and they take that thinking a long way. But also they're very good at. I mean, they invented essentially the word feedbacks. So I think that actually there are many ways in which now, in a much larger, more systematic way, the systems approach to organizations, thinking many areas of biological science. I think we have a big European project on that, and I think it's very exciting, and it's leading us into quite new directions.
But what about this question of what structure exists or should exist domestically or internationally to facilitate and jumpstart this? Any ideas on that?
Well, the RISA projects that Mary mentioned, you mentioned, yes. Rosina, in your lead-in, those are explicitly areas where weather and climate people are interacting with local decision makers as well as people in other fields. I think the question is, Mary, will you be able to expand the RISAs as a model?
I think ideally you would want something built around our geopolitical structure, because that really is how this country works, you know, around cities, around states, and at the federal level. And I think it's really been, you know, certainly beyond our capacity to get to that level now. I will point out, though, that one of the things that we're working hard on is that we are really blessed in this country with a very strong structure for weather services. And we're working in terms of how we take steps to have that structure be able to leverage that to meet some of these greater challenges. And coming back again, we have a very long relationship with the emergency management community, whose lives have gotten incredibly more complicated, and there's going to have to be intersections between, you know, dealing with real problems that we have now versus planning so you don't have those real problems in that fashion. So linkages between city planning and emergency response, and those discussions are ongoing. So I think we need to use all the venues that are available to us.
One more thing I'd like to add is that there are decision makers that are not in the federal and academic arenas now that are starting to really are paying a lot of attention to these environmental and climate related issues. For example, the state of California recently funded a several year long study of the relationship between ocean acidification and the things that local governments and coastal regulators ought to pay attention to. So this is not the kind of traditional way in which studies have been put together and attention has been shifting. So one answer to the question is there are a lot of people who are now interested in weather and climate expertise who weren't there just a few years ago, and that's a trend that I think is going to continue. So be alert to new customers walking through the door.
And maybe just a slightly different dimension to your question here, and that is how do you go about doing international coordination of research that might be related to this? And I do think we do have some frameworks that have worked quite successfully in sort of some of these areas. It's important now that these frameworks, though, actually take a more systems approach. And so, you know, the World Climate Research Program has had a number of really good programs. A lot of those programs, unfortunately, will be ending in the year 2011, 2012, 2013. And it's not clear to me right now what are the successive programs, what are the next set of international coordinated research programs. And that's something that I think we should be really working and taking this sort of message and building into that framework. Another framework that I've been very lucky to participate in is one that's done through the ICSU framework. It's actually a solar terrestrial response type of framework and its connection with space weather and a different type of decision support context than what we're talking about here. But I've been chairing an international coordination program and really moving towards international coordination and collaboration through virtual observatories, virtual institutes, and the ability to actually take take and use our technological information structure to actually ask and do new research questions in an international framework.
Mm-hmm. And we'll have to obviously keep thinking about this. I think the question came in, initially saying there is about a $2 billion U.S. climate change science program, which is focused on the research. Increasingly, we're talking about linking long-term and short-term planning and management and response strategies, and how do you build that parallel capacity and give it strength so that those who manage the lands and waters are interacting appropriately with those who are doing the research. And I think there isn't anything built yet domestically or internationally, but the components exist, and how best to do this is something we'll certainly have to tackle in the coming years. An issue about climate being non-stationary, and in particular, Susan raised this as a question for coastal cities, which implies that, we don't really know what we're optimizing for over what time frame, because past is not prologue. And I guess in many ways we're talking about developing adaptive adaptation for things that are really outside human ken, at least for the last 10,000 years, and happening in all sectors simultaneously in all places. And so a sort of open-ended question about what does this non-stationarity mean for urban planning, but in the context of trying to manage the natural resource base and maintaining those ecosystem goods and services that all of you have touched on in your presentations. So let me ask Susan to start with this very broad question, and others comment on it as appropriate.
Well, certainly, of course, you are really adapting in a way to an uncertain future when it comes to coastal cities and climate change. And of course, a lot of that in my talk was really wrapped around the water issue, whether too much water, long enough water, not enough water, or sea level rise, but it's ultimately how are you going to be managing the water? And in these city environments. Certainly the role of natural ecosystems in terms of providing those buffer zones, those barrier zones, protecting them, putting them back in those low-level elevation, those low-level areas that really provide a planning device in order to actually help mitigate that. But a lot of question is, how much risk are we actually willing to take? Ultimately, it's how much risk are we willing to take? And can we improve, as we go along in our discussions, the measure of that risk and what we can be able to do within that risk. But keep in mind, we're talking about a lot of money associated with this, and so being a little bit precautionary may not be may be a good and wise decision. Many of the states in the coastal regions are pulling together legislative acts. Certainly Massachusetts has passed the Massachusetts Ocean Act. It requires a plan to be developed within the year. I would certainly hope that as other states begin to do these things, that they take a look at what the science and the natural systems can provide, as well as what the built infrastructure needs to do within this context of uncertainty, and try to be able to look at ocean acts and cities in the future. But it's hard. It's a hard question. It's very difficult.
Yeah. Mary?
Yeah, NOAA's really been focused over the last 18 months on trying to get a better handle on the demand for climate information and climate services. And the thing probably the thing we hear most of all is, I'm making decisions today and I don't have the information I need. And in a significant amount of time, we actually don't have that information, but sometimes we do have this information and it's not getting connected. So I think that's one thing not to lose sight of. And then I'd like to underscore, I think, Susan's point about there does have to be a calculated risk assessment made here by the decision maker. So to the extent that we can kind of quantify our information, that's very helpful, quantify our uncertainties. So for example, the city of New York is investing in water infrastructure for the city, and that's a 50, 75-year investment that's here. So it is being carefully looked at. What is the best we understand with sea level rise, extreme events and precipitation, how much more are we going to see? So I think the demand is there. There's significant information we could provide while working on pressing our knowledge base.
Kai and then Julian.
2 points. First, that I think that it's important to be aware that many ecosystem services that are very important to people are not well priced. When we talk about drawing the water out of a river, we talk about the capital facilities that are needed to suck the water out. We don't actually talk about about the value of having the water in the river in the first place, and we treat that as if it were free. Weather science plays a key role in determining the vulnerability and therefore the value to a human society of being deprived of an ecosystem service. And there, I think the weather community meteorological community has a very important role in helping to assess vulnerability, translating them into the dollars and cents and the public health impacts that are the currency with which decisions are made. Secondly, I think a challenge that I'll put to you is that you come from a profession that is organized around the idea of prediction. And its support for resilience, as a number of people have said, is a question of sharing uncertainty, of trying to figure out what kinds of risks can be taken, and assessing those risks in a non-stationary climate where the science is changing month by month and year by year. The product that you're going to provide is not prediction in the usual sense, that there's a 30% chance of a storm surge or whatever. Not only that, certainly, it is also a product that takes the form of a relationship so that you can work with other decision makers to begin to get a better sense of what they care about, so that the farmer that wants to know when the last frost is going to be gets that question translated into a form that a weather person can deal with. So that requires a change in your professional value structure about what you're trying to do and what's valuable. That's not going to be easy to do, but this is the right society to talk about how to do it.
Excellent. Julian?
Well, I'd like to take the last point first. I believe one of the best ways of communicating things is not through numbers, but through patterns. I think we're much more plausible, and I believe the climate community doesn't do enough of that. There are some very patterns in the way in which the atmosphere structures, troposphere is changing, which leads to deeper convection, flow around mountains and so on. And I think it's a much more convincing explanation than sort of arguments about tails of distributions. But the other point I wanted to say about the sea level rise is I think the most important data on sea level rise is happening in the Arctic. I mean, we haven't really touched on that, but I come from a centre called the Centre for Polar Observation and Modelling. I mean, we are having this extraordinary changes in the Arctic. Summer thunderstorms in Yellowknife, where a friend of mine lives. Even Governor of Alaska observes these big changes in climate. We are seeing the melting of the permafrost. These are just extraordinary things, and indeed the reason why I think Susan said that the IPCC estimate was low was in fact the ice is retreating. Most of the models are still very poor on ice edge. I have my own ideas about that, but you know. This is absolutely the most critical area, and there's a new satellite, European satellite, going up this autumn, Cryosat, you know, to monitor exactly how these things are going. So this is absolutely essential. Finally, I just want to make one point. The nicest example of integrated coastline mitigation and adaptation goes back 300 years. The Dutch always put windmills on dikes. Now they're putting their windmills on their big concrete dikes. And the Dutch, of course, are estimating a 6-meter sea level rise, and they're protecting against that. But they're doing it in an integrated way, and that required enormous bureaucratical hurdles to get overcome to allow the dike people to put a windmill on their dikes. That's the kind of thing which many countries of the world need to battle with.
I want to highlight one point that sort of came out here. Some of this is very, very complicated, and we will really have to learn by doing. In some things, though, if you get the right people at the table, you actually can have an occasional aha or eureka moment that says some things really are stupid to do. And looking back, a couple of things from 10 years ago, when we sat down some of the folks who planned for hydro, for salmon, and for people in the Pacific Northwest, when they looked at the projections projections of earlier snowmelt, it was quite clear there's not enough water for the people, for the salmon, for the hydro in the summer. Something fundamentally different had to happen. Same thing turning up now in New York. Same thing, is a wetland a wetland a wetland? Not really. If it's not likely to persist, does it make sense to make it a part of a wetland banking system if it's a prairie pothole that's going to dry up in the middle part of the country, or one that'll be inundated? And so there are some kind of simple decision tools if you think about the suite of parameters across the different kinds of stakeholders together. All right, now we're into our last 5 minutes, and so I would like to give everybody a chance to just comment as a private citizen. Okay, if these issues we've been discussing are so urgent, are there ways that we could think about jump-starting them in either the stimulus package, which, as you know, is something that is kind of a one-time up to 3-year fix, or as we all work to help the government and the international communities think about the budgets for 2010 and beyond? So if you were czar and you're not speaking as a person of any particular organization, some just sort of smart things to do as you think about the stimulus or the near-term budgets. So we start down at this end.
I think the stimulus is a great opportunity to begin to get to plan and execute things from the perspective of green infrastructure. Green infrastructure means thinking about a metropolitan area in terms of its ecological structure as well as its governmental structure, so that the two start to harmonize better. So that, for example, you think about the coastal wetlands as you rebuild New Orleans after Katrina. This means, this means, of course, more effective regional planning, things that are a struggle for American local governments. But it also means something really important that I think that we need to start thinking about, and that is that ecosystem services are valuable. Ecosystems are valuable because of the services that they provide, not only because of the environmental protection that we have already embodied in our law. So switching toward thinking about ecosystem services, thinking about how to plan them on a metropolitan scale, which parts of the wetlands, for example, you want to preserve as suburbanization proceeds. Those are really important things that now we have an opportunity, because the federal government is going to be spending substantial quantities of money, to bring that perspective to bear.
Excellent.
Well, clearly, the message that we have been sending in the action is that we can't be investing in the physical infrastructure in this country the way it's being talked about without a very strong underpinning of environmental information. And there's a number of things that have to happen to support that, including, not the least of which, is having people support decision makers and connect this information. I guess, though, if I was to send a message to this audience, I think our work in Washington would be a lot easier if there was more of a grassroots push from down below. And I think that there are decision makers that are faced with these challenges all the time, and frankly, they don't know where to come and who to talk to about that. So I would really be encouraging us all kind of upping our literacy on some of these topics here and engaging with the decision makers we interact with.
Great.
Well, both these were two good comments. So maybe what I would do is take a look out there, and since this stimulus package is a shovel-ready infrastructure building, I would take a look and really begin to support the shovel-ready observational infrastructure that's really needed to support this ecosystem management approach, this decision approach, and I would be looking at it from a systems perspective. And there's many out there. There's many reports in terms of what's needed for ocean observation systems, for land observation systems, and for atmospheric observation systems, many of which are ready and shovel-ready and ready to go forward.
That's right.
And that provides the underlying base infrastructure that's going to be needed to actually help work with these decision environments.
Julian.
I believe there's a great opportunity for bottom-up, community-based work in climate. In London, we now send out these warnings on health to 4,000 people. We're not getting information back. There have been projects in which communities have responded to how climate and health and so on is changing. And I think this provides a huge opportunity for the information industry and indeed projects going right from satellites through computers, through weather services, through private sector. That's actually something which in the future will become an enormous industry and job creator, but it will also provide the services and indeed the backup, the fundamental community-based backup for dealing with climate. I just want to make my other point is that an ironic point that we actually have a great opportunity because economics is in bad odor. So economists think that they could understood everything, ruled everything. They are hopeless, really. And we're now in a very dynamical world. They deal with, as you know, equilibrium systems. And now I think this is a great opportunity for a new think. And that's the research angle that we should all go out and press for.
Well, we certainly haven't exhausted the topic, but we have exhausted our time. And I want to thank Walt Dabbert for making us take on this complicated and important topic.
Think Forward. Think Research Channel.